Hello everyone, this is our second video lecture regarding solution chapter for a plus 2 class. Hope you understand the last lecture also. So now in this lecture we will discuss some concentration terms which are used for solutions. Then we will discuss the term solubility. Then we will discuss the solubility of a solid in a liquid. Then we will discuss the solubility of a gas in a liquid, and then we will discuss a solubility of a solid in a solid type solutions. Moving to the first topic is the concentration terms of solutions. So here our first concentration term is mass percent, and mass percent can be calculated by using the mass of a component divide by the mass of the solution multiply by 100. So if you want to calculate the mass of a solute, then put the mass of solute here and then total mass of the solution where mass of solvent plus solute came here and then multiply with 100. Now moving to next term, which is volume percentage. Here volume percentage we will put on the place of mass volume of a component, then divide by the volume of solution. The rest of the things will be similar. Then mass fraction. Mass fraction is the mass of a component divided by mass of a solution. So it is similar with this. No, only change is that we will not multiply with 100. This is your mass percentage. Okay, so mass percentage and this is your mass fraction. Now moving to next term with this mole fraction. So mole fraction is number of mole of a component divided by total moles in a solution. Okay, now next is ppm, parts per million. Parts of a component divided by parts of solution multiplied by a million 10 raised to power 6. This ppm term is used to check the purity of a water, hardness of a water or a purity of a air. Next term is your molarity, which is denoted by capital M. Gram moles of a solute divided by volume of a solution in liters. The next is molality, small m, gram mole of a solute divided by mass of solvent in a kg. The next term is normality, denoted by capital N, which is gram equivalent of a solute divided by volume of solution in liters. So you can see that this molarity and normality are similar, only the change is here. Okay, the basic down terms are similar. So if you want to change this liter into ml, you have to multiply here with the 1000. Same with this. Okay, so now the next relation between the normality and molarity, we will have molarity, normality into small n, where n is your number of moles. Now moving to next, normality of acid can be calculated by molarity into basicity. That is your the H positive atoms which are available to donate from an acid is its basicity. For example, in HCl its basicity is 1 because 1 H positive can be donated. Then normality of base can be calculated as a molarity multiplied by acidity. Acidity means the base in which there is OH negative easily available. So it will define its basicity. Then molarity on mixing solutions. If we have a two solution, then their molarity will be M1V1 plus M2V2. Then the total molarity of a mixture by mixing both the solution will be M3 into V1 plus V2 because volume is common, molarity will vary. Same with the normality, we have a two solutions, one with N1V1, other with N2V2. Then by mixing the both, we will get normality N3 and a volume V1 plus V2. Next, this is our molarity versus molality. Okay, so we know that in molarity and molality, one thing is different, that molarity will consider R, this term, that is mass of solvent, but molarity covers volume of solution. So if we check both terms in our daily life, we will see that with change in temperature, this molarity changes because volume decreases with increase in temperature, but this mass of solvent remains same. So we can say that this molality small m term is independent of mass, therefore it is better than molarity. This is what I have written here also, that it is independent of temperature, therefore it is better than your molarity because it get affected with the temperature. This is your molarity versus molality or normality versus molarity. Here we have a normality equals to weight of solute in gram divided by equivalent mass into volume in liters. So this we have discussed. For a solid we will use this valency. Now our next topic is solubility. So in solubility we can check the solubility by putting solute in solvent, and we can see that how much this solute can be dissolved in our solvent. This simply depends upon the nature of the solute, nature of the solvent, and our temperature and pressure conditions. Okay, so firstly we will discuss solubility. So solubility is defined as the amount of a given substance that can be dissolved in a certain amount of a solvent, which means that we can say that it is a maximum amount which can be dissolved in a specified amount of solvent. For example, if we have this amount of solvent, we can add solute depending upon this solvent concentration. After this solvent is completely dissolved and a solute take place here, so if we add a more solute it will not get dissolved and it will get separated here like this. So if we increase the solvent quantity, then we can add more solute easily, it get into the solvent. Simply thing is this, that we have this much amount of solvent, we will add solute, it will go like this. And if we have a different nature solvent and different nature of solute, then the solute will not dissolve in a solvent, it gets separated here. Like for example, we can have a benzene as a solvent and we add NaCl, which is a polar. So benzene is non-polar organic solvent, it will not dissolve in benzene, so it will get separated here. Next is our two type of concentration solutions. One is dilute, second is concentrated. We have a same containers, we have a same quantity of water, we add different quantity of solute in both the containers. The container which contain lesser amount of solute will known as having a dilute solution, and the container which contains more solute particles in comparison to first chamber will known as a concentrated solution. So the concentrated solution is nothing else but only the quantity of solute is larger in comparison to our dilute solution. How solution forms, we will see here that this is our solvent, this is our solute. We know that solvent have a gap between the particles, even solute have a gap between its particles. So when we mix both solvent and solute, this solute particle go into the vacancies present in the solvent particles. So this is the scenario and this is what we get after mixing of solvent and solute. This is our example like water plus salt. So this is our solvent, this is our solute. When we mix this into this, the same thing will happen like this, that in water we have a here in the amount of salt. Same with sugar, when we dissolve sugar in water, we get the same scenario there here in the where the gaps are present in a water, the solvent then solute after adding in solvent get place their vacancies. This is the process of solubilization. The holes open in a solvent are like this, and when the solutes are broken away and these solute particles get into the holes present in our solvent. Now our type of solubility. First type of solubility of a solid in liquid type solution is we have a solid solute in a liquid solution or a solvent, then we put this solute into solvent, we get this type of holes, and we know that they mix with this and the solution will look like this, a blue and red balls like solute and solvent mixed here. This is what we have seen, that when a solid solute is added to the solvent, some solute dissolve and its concentration increases in the solution. This is a good example of NaCl, where green balls represents the chloride ion Cl negative ion and these white balls represents Na positive cation, okay, sodium cation. So this is our water, oxygen and two hydrogen, H2O. These water molecules, 4 water molecules are present here on the screen, and two hydrogen with one oxygen. Red ball represents oxygen. So when we add salt in water, we see that this oxygen this oxygen, which is negatively charged, surrounds the Na positive cation because opposite charges attract each other. So from water, oxygen O negative. Okay, oxygen carrying a negative charge, partial negative charge, surrounds our cations, sodium, and our hydrogens, which are partially positive charge, will cover our chloride ion, which is negative. This is known as your dilution. So this is what we see, that actually this thing happen in a glass of water when you add salt in a water. So I hope next time when you are going to have a salty solution, you can think over this, or this picture remembers in your mind. Now, what are the factors which affect this solubility, that whether the solute will dissolve in solvent or not? So, there are basically, first is the nature of the solvent and solute. Here we simply know that like dissolves, like the same phenomena happens in our life also. We have a friend of a similar taste. So, this is what actually like dissolves like. So, we have a three type of solutes and we have a two type of solvents: polar solvent and non-polar solvent. Okay, polar solvent are the solvents which are carrying a positive or a negative charge, or a charge separation is there. But in non-polar solvent, no such type of charge separations will be there. There are no charge particles in a non-polar solvent. In a polar solute, we can have a charge particles. In ionic we have a charge particles, but in non-polar there is no charge particles. Okay, so moving with the first case, that is we have a polar solvent, for example water. We have a polar solute, for example NaCl. Both are polar, we dissolve, they get dissolved. But if we add polar solute in a non-polar solvent, okay, we discussed like benzene and NaCl, then it will not dissolve, so this is not soluble. Same with the next ionic solute, it will also have a charge, so it will get into the polar solvent only, it will not dissolve in non-polar solvent. Same with the third case, that is your non-polar solute, it doesn't have any charge, so it will not get into the polar solvent but get easily dissolved in your non-polar solvents. Second is the effect of temperature. The effect of temperature is simply, we know that there are two type of reactions or processes. One is endothermic, second one is exothermic. Okay, so directly proportional the temperature is directly proportional in endothermic reactions. If we increase the temperature, the solubility of solute in liquid increases, and if we decrease the temperature, the solubility also decreases for these type of solutes. And for exothermic reactions, this dependence is inversely. If we increase the temperature, the solubility decreases. If we decrease the temperature, solubility increases for these type of solutes. Okay, now moving to the third factor, that is effect of pressure. The pressure has a very little effect on the solubility of a solid in a liquid, because solid and liquids are not highly compressible. They have a lesser amount of gap present in a solute or solvent in a solid in a liquid type solution. So pressure affects very little in a solid in liquid type solutions. Moving to our next second type of solution, that is gases in liquids. So we will discuss the solubility of gases in liquids. We have discussed this thing in the last lecture also, where we discussed the Henry's law. Okay, so solubility of a gas in a liquid depends upon the pressure applied on a gas. Okay, so we can dissolve gases like HCl, ammonia, carbon dioxide. It depends upon the temperature, pressure, and the amount or quantity of a gas is present. Okay, so this is what our gas liquid solution. We can see that there are two type of factors on which this solubility depends. First is nature of a gas, second is nature of a liquid. Okay, so it depends upon the gas whether it get into the solvent or not, or it depends upon the liquid also, that it is able to get a solute as a gas or not. Okay, so here we have a HCl gas, we mix it with the water liquid and we get this chloride ion and H2O positive. This is the scenario. After mixing of HCl and water, we get this type of a thing. So we will discuss here factors which affect the solubility of gases. Here I have written some gases which are present, and we simply say that the larger the gas molecule, okay, or larger the molecular mass of a gas is, greater is the solubility of a gas in a liquid. because due to the greater forces of attraction between the solute and the solvent. So that is the reason that we mix carbon dioxide easily in our soft drinks in factories. Okay, so next is term is solubility of a gas in liquid, that how gases get into a liquid, how they get soluble in liquids. So simply here we have a one chamber in which we have a liquid, we have a gas, and we have one piston. W1 is the piston weight which we pressurize or which get pressure on a gas. So this weight is not that much, so that the gases are not get into as much as it is happening here. Here we have a three weight, so more gas will get into the liquid, so this level decreases in comparison to a chamber. Now this is what happened when pressure is increased on a chamber. They say that when the pressure is increased over the solvent, the solubility of gas increases because pressure increases as a gas molecule strike the surface to enter the solution is increased, because when we increase the pressure, this chamber get in, and these gas particles which are away from the liquid get close to the liquid, and they have no place to go, so they get into the solvent. This is what a Henry's law say, that solubility of a gas is directly proportional to the partial pressure of the gas above the liquid. Okay, now this second is effect of temperature on the solubility. So we have a two bottles or cold drink bottles. We can say that as temperature goes down, temperature decreases, solubility of a gas increases. But as temperature increases, the solubility of a gas decreases, which means that here temperature is lesser, so this gas is dissolved here in a liquid. But as temperature increases, this gas which is dissolved here get evolved and released from the liquid, so the solubility decreases. This is what we can say, that effect of temperature. We have a chamber, we have a needle, temperature, and carbon dioxide. This shows that for if a needle is on left hand side, for low temperature, on the right hand side needle is on the higher side, so temperature is high. So we say that if temperature is lesser, the little carbon dioxide is free. Okay, so maximum carbon dioxide is dissolved in our liquid, but when we increase this temperature, the carbon dioxide which is dissolved in a liquid get evolved from here, and here the quantity of carbon dioxide is more. This needle represents the more quantity of carbon dioxide which is evolved from this liquid. Okay, so in this liquid there is more carbon dioxide because this system is at a low temperature, but here this system is at higher temperature, so here high temperature and lesser carbon dioxide present in a liquid and more is outside the liquid. So we can say that pressure is the only thing which affect the gases in liquid type solution. Okay, so we can say that pressure increases, solubility of a gas in a solvent increases because forces it forces gas particles into contact with the liquid. So the gas particles have a weak attraction, so they get into the liquid easily. This is what basically the application of Henry's law, which we can demonstrate here, and I think now you can easily understand this thing, that we have a cold drink chamber and we can say that this is closed. That means the carbon dioxide is under high pressure, lot of carbon dioxide is dissolved in a liquid, so this thing is represented as a hair. But when this is open, the pressure is released, more carbon dioxide get released, so there will be lesser carbon dioxide present in this drink. So this is the effect of pressure. We can easily see when this seal is closed, then the carbon dioxide is dissolved in a liquid. The time we open this, the carbon dioxide get evolved by producing a fizz like sound, and the solubility of a carbon dioxide in liquid simply decreases. This is the effect of temperature on different solutions, as one is a solid into solvent, other is a gas into solvent, means solid in liquid and gas in liquid. So in solid in liquid type, the solubility increases as we increase the temperature, and in the gas in solvent the solubility decreases with increase in temperature, because here temperature increases and here the term solubility increases. This is our third type of solutions, that is solid and solid solutions. Okay, these are two type of further substitutional and interstitial. The substitution allow further two types, disordered and ordered. What what is the type of solid solution? There are two types, substitutional and interstitial. In substitutional, simply solute particles replaces our solvent atoms and get into their place, but in interstitial they simply occupy their interstitial positions or the gaps which are present. So this is our interstitial, where solute get into the vacancies present in the solvent particles. This is our substitutional. So earlier here all the balls are green, means all is solvent, but the time we add a solute it will get replaced the alternative particles and get into their place. Okay, in interstitial the solvent is as such, but the time of addition of solute they will get into their interstitial sites. This will happen if we have a solvent particles of larger size and solute particles of smaller size. This is a substitutional. Okay, so this is a parent atom, that is a solvent, and when we add other type of solute then it will displace their atom position and get into their place. This is the interstitial, then solute particle get into the traps or a gap or a voids present between the solvent metal atom. Thank you, hope you like this video. Share it with your friends. If you know them they have some problem, then you may ask in a comment section. Thank you.